On to section 5 of chapter 1. We're going to take a little trip to graphs where we'll talk about points and ordered pairs, quadrants and scale, graphs of equations, and then nonlinear equations. Now, if we imagine a graph is made up of two number lines, one horizontal, which is called the x-axis, and the other vertical, which is called the y-axis. And we're going to work on what are called ordered pairs. Now, an ordered pair, by its definition, is in a certain sequence. The x always is followed by a y. This is an ordered pair. So when you go to plot a point that is an ordered pair, you start on the x-axis, and since this point is 0 for the x and 0 for the y, it's called the origin and is written 0, 0, as is shown there. Now, if we want to plot 2, 4, again, we start at the origin and move 2 to a positive direction, and then up 4 in a positive direction to get to the point 2, 4. Now, this one is going to be 4 as the x coordinate, and then up 2. So this would be 4, 2. And we'll go on. They'll give us some to do. So plot these points. Now, they don't really have a x and y axis, so we'll have to put that in first. So this will be our x, y, and this will be our x. So in plotting points then, we're going to start at 3, 4, so there's 0, 1, 2, 3, 1, 2, 3, 4. And we'll just put it there, 3, 4. And then -2, 0. So we'll start at 0, go over to -2, and we don't go up or down. So this would be -2, 0. And for this one, we're going over 4.5. So there's 1, there's 2, there's 3, there's 4. So we go halfway and then down 2. 1, 2. So this will be 4.5, -2. And the last one is a -1, -5. So we start at 0, go left 1, that's -1, and then down 5. 1, 2, 3, 4, 5. So -1, -5. So this is the way we plot ordered pairs. We always do the x first. That's going to be right or left, depending on its sign, and then up or down for the y. And there they are. Now, when we have these two number lines made up of the x number line and the y number line, it divides our plane into 4 parts, which are called quadrants. So here is the first quadrant, and they're usually indicated by Roman numerals, the second quadrant, the third quadrant, and the fourth quadrant. Now, an interesting thing about these, that in the first quadrant, both coordinates would be positive. In the second quadrant, the x is negative while the y is positive. In the third quadrant, both are negative. And in the fourth quadrant, the x is positive, but the y is negative. Often you're asked what quadrant is something in, so this is the layout of it. Now we also find that sometimes something is on the x-axis here, or something is on the y-axis. In these cases, these are not in a quadrant. We say they are on the axis that they're on. Here, this would be the x, this would be the y. Now, if we have a series of points, and these points are all in a straight line, they make up what is called a linear graph. That is a graph that is a line. Okay? So let's check that out. Now, a little later in chapter 2, we're going to go over this particular equation right here. And this is in the form of y equals mx plus b. And I'm going to assign this the number of 2. We're going to call that equation 2. Well, this is called slope-intercept equation of a linear equation in 2 variables, a y and an x. Now, what we want to do here is to determine whether these points are in this equation, and that is make this equation true. So you might say, how do we do it? Well, we do some substitution. Here is our equation. So what we do is we substitute into our equation the x value, which is 2 here, and the y value, which is 5, which I've done here. So 5 equals 4 plus 1, which is 5. So this is a solution for this equation. That means that ordered pair is a solution for this. Now when we put the negative 2 where the x is and the 1 where the y is, we get 1 equals, this is a negative 4 plus 1, a negative 3. So this one is not a solution. Now another type of example they're going to give us and they want us to work on is to graph a particular equation. Now in order to graph it, we have to have axes. I'm sort of surprised this doesn't have axes, so let's set them up. This will be our y, and then this will be our x. Okay, now we can graph it. And what we do is we often make a little t-chart. And this is important. And we put our x value there and our y value there. And then what we want to do is to get various values that we're going to put for x. A good one is a negative 1, a 0, and a positive 1. Now, why am I using these values? Well, because they're right down in here near our graph. I wouldn't want to use a negative 10. That's not on the graph. Okay, so we pick values that would be within this origin region. So if x is a negative 1, and we just put it right there, negative 1 plus 1, then y is going to be 0. Now if x is a 0, this is a 0, y equals 1. And if this is a 1 here, y equals 1 plus 1, which is 2. I now have 3 points that are solutions for this linear equation, and I plot them. So -1, 0 is right there. 0, 1 is right there. And 1, 2 is right there. Now notice I have a straight line. And if I take my line tool, it ends up looking like this. All right, for these, a straight edge is good. Now, are there other points along this line? Well, let's just take a look. For instance, right, let me change colors here, right there. What is this point? Well, this is going to be 1, 2, 3, 4. And this is going to be 1, 2, 3, 4, 5. Now, would 4, 5 work here? That y would be a 5. X is a 4 plus 1. Yes. So how many points are in this line? And the answer is there is an infinite number of points along this line. This extends on to infinity in this direction and on to infinity in this direction. But that's a typical graph of that equation. How did I get it? I made a t-chart. I picked out some common points, solved for the letter y, plotted them, and they are, in fact, in a straight line. If you do a t-chart like this and you get points that are not in a straight line, if it's a linear equation like this, then you've made an error. By definition, this is a straight line equation. So that's their t-chart, and they made it a little bit to the side, and there's the line. Notice we had this point, and this point, and there's an infinite number of points along this. All right, how about this one? Well, again, we're going to use the same technique. Make a t-chart. X there, Y there. Now, here's the case where we're not going to choose a 1. Why? Because it would give us a fraction. So we're going to choose a -2. Always like to choose a 0. And we're going to choose a +2. Why did we choose 2's here? Well, because when we multiply, they cancel out nicely. So here, if this is a -2, this becomes a +1. If this is a 0, then y is a 0. Now, if this is a +2, again, the 2's cancel out, and I'm left with a -1. So there are my 3 points, and I'm going to make a graph. And notice what I get. A point there, a point there, and a point there. And I take my line tool. Now, as you do this in MATLAB, they have a nice line tool there as well. In fact, better than this one. I missed that point a little bit there. Okay, again, it's supposed to be a straight line. But we'll see it in their graph. There you go. See, they're off a little bit right there too. See, they didn't quite get it to go through 0, but I was pretty close. Okay, if you have a graphing calculator, there is a technique, and I can show it to you if you'd like. But again, we don't expect you to have one, but this is how you would plot it. Go to graph, y sub 1 equals negative 3x, and then you hit plot or graph and you end up with this. They're very nice. Now how about whether a graph is linear or non-linear? And the difference, by the way, is whether the equation, and there's two basic linear equations, actually there's a few more than that, there's four basic ones, but it would be like this: ax plus by equals c, that's one. And the other famous one is one we did for number 2, which is y equals mx plus b. And then there is y equals b and x equals a. These are the four main linear equations. Notice that the exponents on the variables x and y are all 1. Here this is just a 1 and this is just a 1. Okay, so if that is true, they are a linear equation. Now, graphs of nonlinear, and we're not actually going to be doing much of them, although just to fancy it a little bit, let's take a look at one. Now, notice this is sort of in slope-intercept form, but here our x is to the second power. Anytime you have either x or y to the second power, you get not a straight line, but a curve. And this one happens to be, after you plot some points, a parabola. But again, we're not going to be working with that, particularly in Math 100. And there's another type that we're not going to be working with. These are absolute value equations, and we're not doing that either. Okay, and that will wind this up.